Hey guys, so we're at 9.2, circumscribed angles. So in 9.1 we talked about central angles. Okay, central angles are angles, let me do a little graph of it, maybe if this was our circle. Central angles are angles, central angles are angles where the vertex of the angle is at the center. That's the word central angle. All right, and we said that the angle and the arc are the same when you have central angles. Okay, all right, and then there is inscribed angles. So inscribed angles are angles that are at on the circle. All right, and here we learned that the arc is equal to 2 times the angle. Right, so that's something special about inscribed angles. And then today what we're talking about is circumscribed angles. All right, so circumscribed angles, the vertex of the angle is outside of the circle. Okay, and we'll talk more about that as we get further on. Okay, but before we do that, let's talk a little bit about tangents and secants. Okay, a tangent line is a line that intersects the circle only one time. Okay, and the radius and the tangent are perpendicular. So if we look at this graph, I mean, it kind of looks like it's not really on it, but the tangent line only crosses the circle at one point. Okay, and I think somebody changed this around. Okay, so right here, and the radius that connects this tangent is perpendicular. All right, and that's something special about tangent lines, and we can talk about that some more. So just remember that tangent line only touches the circle one time, and it is perpendicular to the radius all the time. Okay, so this would be tangent. Okay, and if you were to write down this line, you would write it as RT, and you would put an arrow on top of it because it goes on forever. Okay, so that's how you write down a line. All right. Also, we have point of tangency. So point of tangency is the point of intersection where the tangent touches the circle. And a secant is a line that intersects the circle twice. So here we have this line, okay, something like that. And if you were to write that down, let's come up with some letters for this. Let's do A and B. So we'd write this as A, B with an arrow on top. Okay, so a secant touches the circle twice. All right, so let's go look at two tangents. If we did two tangents, it would look something like this. Okay, and we're always going to want to have these tangents. I've had someone say, well, this is a tangent, because I just disappeared. These are two tangents, okay? But really what we're trying to find out is what is this angle when we do our tangent, okay? So this is your angle. This, let me change my color. This part right here is going to be your minor arc. And then the green, that is your major arc. All right, and there's a special relationship with the minor arc, major arc, and the angle, and that is shown here. So the major arc minus the minor arc, divide that by 2, and that will give you your angle. Okay? So let's look at these problems real quick. And we're going to use this all the time. So like, for example, when we did our central angle, we knew the situation that the angle is equal to the arc. And when we did inscribed angle, we knew that the angle is 1/2 the arc. Okay, or you can also write this as the arc is equal to 2 times the angle. So if we multiplied both sides of these by 2, we'd get this part, okay? All right, so let's see if we can use this equation to solve this problem. All right, so we have this major arc, and the equation, we also need to at least know 2 of the 3 things. We need to either have the major arc, or we need to have the angle arc, or angle. And we're looking for the angle, so we need to find out what this minor arc is. And you may think, well, Mr. Warner, a circle is 360 degrees, so the small part that is, we could just do 360 minus the major arc, and that would give you your minor arc. And I would say, yeah, you're right. Thanks for pointing that out. Okay, so now we have our minor arc and our major arc, and our angle is going to be 235 minus 125, divide that by 2, right? And you do that, you can plug it in your calculator. That would give you 110 over 2, or 55 degrees. Okay? All right. So let's look at this one. This one's a little different, and this won't be on the test, but let's see if we can figure it out. All right, so if we put a center point on there, and they give us this angle, how could we by chance find this major arc? All right, and you may want to think about that. It has something to do with this. Okay, so if we draw a radius that connects to the point of tangency, sorry if I'm going all over the place, so this would be like our point of tangency, and this would also be our point of tangency. We can connect those two, and we told us before that a tangent and its radius will always give us a 90 degree. All right, so now we know that this is 90, and this is 90, and we know that this is 75. All right, and with any type of quadrilateral, any shape that has 4 sides, all the angles add up to give us 360. So all we would need to do to find this part, we would need to do 360 minus 90 minus 90 minus 75. Okay, and that would end giving us 105. Okay, so we have this is 105. This is also our minor arc is 105. So if we were trying to find this question mark, the major arc, all we'd need to do is 360 minus 105. That gives us 255. Okay, so like I said, that for B you can't use the equation that we have up here, but this also won't be on the test. But you could probably come up with this by yourself. I mean, it's not too bad as long as you realize. You just realize that the radius is perpendicular to the tangent. Okay, so it's the same with C. Okay, although you don't have to do as many steps, you'd still know that these are right angles. So we want to find this question mark, which is the same as the angle, because this is a central angle. So with a central angle, you know that the angle is the same as the arc. So all we need to do is 360 minus 90 minus 90 minus 65, and that would give you 115 degrees. Okay? All right, so again, I said C and D. It won't be on your homework. We won't have quizzes on that. All right, D. So if you If you can, please pause and see if you can do these problems by yourself. And if you feel like you're already caught up with this, then just kind of go past this and see what we're learning next. All right, so here they give us an angle and they give us the minor arc. And it doesn't say anything, but we're going to want to find what x is. Okay, so how we're going to do this is we can say that the minor arc, we can find out what our major arc is. That's going to be 360 minus 14 plus 8x. Okay, or that would give us 346 minus 8x. And then we could come up and do our equation. So we'll do our angle equals to the major arc minus our minor arc divided by 2. All right, and then you're just going to need to do a little algebra, multiply both sides by 2. That would cancel. We get 140 equals 346 minus 8x minus 14 minus 8x. So we need to distribute that negative. That gives us our negative 8x. All right, and then we would want to combine like terms. And we would maybe want to subtract 346 from both sides. Okay, so those would cancel. And give me a second to calculate this real quick. Can't do this in my head. 140 minus 346 minus 14. Okay, that gives us a negative 220, and we'd add up those negative 8x's, which give us negative 16x. And then we just need to divide both sides by a negative 16. Oops, I did that wrong. 220 divided by 16. All right, and that would give us, dagnabbit, I think I did something wrong. Give me 1 second, otherwise I might just go past. No, that's it. We need to plus 14. Plus 14. That would give us 192. Divide that by negative 16. Okay, and that would end up giving us x equals 12. All right, sorry about that. Okay, and then since we just need to find out what x is for this problem, we've got it set. If they asked us what, like, say, sometimes they may ask what's the major arc, well, then what we just need to do is plug that into our equation. Or if we needed to find the minor arc, we could just plug that in there, okay? All right, sorry about that. Again, if you feel good with these, just go on to the next one. We get the other side of the homework, or the test. Notes, gosh. Okay, so for this one, they give us a major arc. Okay, we may want to write down what the minor arc is. So to find the minor arc, we'd do 360 minus 226. Okay, 360 minus 226. That gives us 134. Okay, and then we can use our equation. So we know that our angle is 6x plus 4. Our major arc is 226 minus our minor arc, 134, divided by 2. Okay. 26 minus 134 divided by 2. Okay, so that gives us 6x plus 4 equals 46. Would subtract 4 from both sides. Would get 6x equals 42. And then would divide both sides by 6. All right. And that would give us x equals 7. All right, so all we need to do now with that 7 and plug it into our equation, we would get 6 times 7 plus 4. And that would give us 46 degrees. Okay? All right. Next one. All right, so this one, we would use all 4 of them, and this is kind of hairy. Okay, so we'd use our equation. This would be our angle, minor, and major arc. So 25. Actually, there's another way you can do it as well. You could plug that all in, and that would be fine. Or you could realize that this circle is 360 degrees. So you could also say, you get the same answer. So here you could do 5 plus 60x plus 118x minus 1. That all adds up to give us 360 degrees. Okay, so from here you could combine like terms. You could add 1 to both sides, and you could subtract 5 from both sides. All right, and combine these like terms. 118 plus 60 is 178. X equals 356. Then we just divide both sides by 178. 356 divided by 178 gives you 2. X equals 2. And then, since it doesn't ask us for a specific part, then that would just be our answer. Okay, but you could, like I said, you could plug these in here, and you could find the angle, major, and minor arcs. Okay, all right. Sorry, I feel like this is kind of going slow. Please forgive me. All right, so we just barely talked about tangents. So we could have a circle that has 2 tangents, like this, but we could also have secants. So if we had 2 secants are the lines that go through the circle twice. So this could be a secant line. Okay, so here it connects, each secant crosses the circle 2 times. We could also have a secant and a tangent. So here we could have our tangent that crosses right here, and then it could also have a secant that crosses through as well. Okay? And you will treat them exactly the same as you do if it was just 2 tangents. So for example, you're still going to do angle is the same as the major arc minus the minor arc divided by 2. So we could say the angle, we'll just say a question mark, equals 155 minus 85. Divide that by 2, and that will plug that in your calculator, and that should give you I think I did it wrong on my paper. 155 minus 85, divide that by 2, and that gives you 35. Okay, so that would be our angle. All right, let's look at this one. This is very similar, except this time they give you everything except the major arc. So you would write down and say Well, our angle is 60 degrees equals the major arc, we'll just put a question mark, minus our minor arc, which is 57, divided by 2. Okay, so here we can multiply both sides by 2. That cancels out, we get 120 degrees equals to question mark minus 57 degrees. And then we would just add 57 to both sides. That would cancel, and we would end up getting our question mark is equal to 177 degrees. All right, here's another one. Here all they give you is the minor arc, but we can handle that because we know that a circle adds up to give us 360. So we can go 360 minus 110, that gives us 250 degrees. Now we have our major and we also have our minor, so our angle, our question mark, is 250 degrees minus 110 degrees divided by 2. Okay, and that would give us 140 divided by 2, or 70 degrees. All right, next one. Again, feel free to pause if you want to try and do it by yourself. Same thing, they give us, we want to find our angle. We know our major. We have our minor. Divide that by 2, that gives 100 divided by 2, which is 50 degrees. All right, and then there's another way to do these where you have to solve for the x value. So solve for x, assume that the lines which appear tangent are tangent. Okay, so obviously neither of these are tangents, they're both secants. Okay, so we have our angle, and we have our minor arc, and we have some sort of equation for our major arc. So we're going to need to solve for that. So our angle is 40 degrees equals to 38x minus 2 is our major, and then we'll subtract our minor, and we'll divide it by 2. We'll divide or multiply both sides by 2. That cancels. That gives us 80. I didn't do that very well. 80 degrees. Oop, kind of messed up again. 80 degrees equals to 38x, and we can combine these two, combine like terms to give us a negative 72. Next we'd add 72 to both sides. Okay, 80 plus 72 is 152 equals 38x, and then we divide both sides by 38. 152 divided by 38, that gives us x equals 4. And that's all they're asking for. All right, this next one, like it says, if it appears to be tangent, we're just going to say that it's tangent. I'm not going to prove that they're tangent. So here they give us the major arc. We can find our minor arc by doing 360 minus 255, which gives us 105 degrees for this part. And we would do the same thing. We'd do 10x minus 5 is our angle, equal to our major arc minus our minor arc, divided by 2. All right, 255 minus 105 gives us 150, and we'll divide that by 2. So we'll get 10x minus 5 equals 75. We'll add 5 to both sides. We'll get 10x equals 80. And then we will divide both sides by 10. And we get x equals 8. That's all we need. Okay, so I think that covers everything. Just in case you weren't there in class, our homework, we're only going to do the evens. Oops, I just want to write on that. We only want to do the evens. Okay, and you do not have to do 3 and 2. Okay, those are the ones that I told you where you would need to come up and put a center and realize that these are perpendicular, and you'd be able to solve the problem that way. It's not hard, and if you do it, and if you do the odd problems as well, I can give you extra credit. Okay? All right, well, enjoy, and let me know if you have any questions.